How about some properties of radicals? Okay, now we need to talk about rationalizing the denominator. Whenever that happens, it's asking you to get the radical out of the denominator. If you have two terms, you just need to multiply by a really clever form of 1. We're going to multiply by the conjugate of this. That means you just change the sign. That's it. You just change it to 6 plus the square root of 2 over 6 plus the square root of 2. Okay, if you multiply those, then you won't have a radical in the denominator anymore. So let's multiply everything in the numerator out. We would get 2 times 6, 2 times the square root of 2, the square root of 10 times 6, and the square root of 10 times the square root of 2. How about the denominator? 6 times 6 is 36. 6 times the square root of 2 is 6 square root of 2. Negative square root of 2 times 6 is negative 6 square root of 2. And negative square root of 2 times square root of 2 is negative square root of 4. Now we simplify as much as we can. In the numerator, we have the square root of 20 here. Square root of 20, well 20 will break down into 2 times 2 times 5. So the 2's can escape, and we'll have 2 square roots of 5. So in the numerator, we will have 12 plus 2 square roots of 2 plus 6 square roots of 10 plus 2 square roots of 5. In the denominator, we have 6 square root of 2 minus 6 square root of 2. Those are alike. Those will go away. Well, what is the square root of 4? The square root of 4 is 2. Well, what is 36 minus 2? 36 minus 2 would be 34. Now you could actually reduce this because 2 will divide into everything. So we would actually get 6 plus the square root of 2 plus 3 square root of 10 plus square root of 5 all over 17. So the whole point to this was to get that radical out of the denominator. So what if you have one like b? Remember, you need enough under here to put them in groups of 5 so that everything can escape. Well, I already have 1 3 and I have 1 y. If I need them in a group of 5, I'm going to need 4 more of each of them. So what I do is multiply by the 5th root of 3 to the 4th, y to the 4th. That will give me 4 more of each of those factors. 3 to the 4th, y to the 4th. Now let me write that out so you can see what it looks like. 4x times the 5th root of 3 to the 4th power would be 81, and then y to the 4th. All over. Well, in the denominator, we're going to have the 5th root of 3 to the 5th, y to the 5th. Well, look what happens. We have 5 3's, we have 5 y's. They all get to escape, but of course, only one survives. So we're going to have 4x times the 5th root of 81 y to the 4th all over 3y. So on this one right here, we are going to have to do the same thing that we did on that last one. We need to, first of all, figure out how many we have under here before we do anything else. So we're going to break down this 32. What would that be? 4 times 8? So 2 times 2 2 times 4, 2 times 2 times 2 times 2 times 2. So what we have would be, have a look over here, we have a 3 right here. So we know that they're going to need to be in groups of 3. So we have one group of 3, but then we only have 2 more 2's. We're going to need 1 more 2 for all the 2's to escape. And how about the x's? We have 1 x. We're going to need 2 more x's. So you multiply by the cube root of 2x squared over the cube root of 2x squared. So you end up with 3 times the cube root of 2x squared all over the cube root of, now I'm going to use the 32x from over here, so that would be 2 cubed, and then we have these 2 2's and this 2, so that would be 3 more 2's, and then we have x times x squared, which is x cubed. Well, remember, if you take the cube root of something cubed, then the cubes go away. So you end up with 3 cube root of 2x squared all over these escape, and these escape. So 2 times 2 times x, or 3 cube root of 2x squared all over 4x. Okay, for b it's a little bit different because we have 2 terms. We need to multiply by the conjugate. So we multiply by the square root of x minus the square root of 2y. So in the numerator, we're going to have y times the square root of x. We're distributing this, minus y times the square root of 2y. And in the denominator, we're going to have the square root of x times the square root of x, square root of x times negative square root of 2y, square root of 2y times the square root of x, and square root of 2y times negative square root of 2y. Back to the numerator, y square root of x minus y square root of 2y all over square root of x squared is x. I messed up a sign here. Let's see. This times this is negative, but this times this is positive. Okay, so these two go away because this negative and this positive make them go to 0. And then we have minus, well, the square root of 4y squared would be 2y. And that's all you can do to this one. Okay, one more problem. Rationalize the numerator this time. That's not something you do very often, but they're asking for it in this program, so we'll go ahead and work it. If you want to rationalize the numerator, you work it the same way. You're just going to multiply this by the conjugate of that. So the square root of 7 plus the square root of 2. So in the numerator, square root of 7 times square root of 7 is square root of 49. Square root of 7 times square root of 2 is the square root of 14. Negative square root of 2 times the square root of 7 is negative square root of 14. And negative square root of 2 times square root of 2 is negative square root of 4. All I'm doing, in case you're wondering, is just distributing this to everything and then this to everything. That's all. In the denominator, I just multiply everything by 1. So we get square root of 7 plus the square root of 2. So back to the numerator. We have the square root of 49. Square root of 14 minus square root of 14 is 0. And square root of 4 is 2. Seven minus 2 is 5. Now the key is you're not supposed to leave a radical in the denominator, but since they actually asked us to rationalize the numerator this time, then you have to leave a radical in the denominator. Hope that didn't confuse you too much. See you in the next one.